Good morning, Veritas. It is Thursday, April 16th, 2020. I hope everybody's doing well and staying healthy. We have today and tomorrow, and then you are on April vacation for a week. So let's work hard today, work hard tomorrow, and you'll have a week off. So let's get right into it. And here we go. Okay, so here's your lesson posted on Google Classroom for today, Thursday, April 16th, 2020. There's 3 problems as usual. Number 1 says evaluate the following expression. Now, if you don't know what evaluate means, and you don't know what an expression is, evaluate the following expression. It's telling you that this is an expression because it's following, right? So this is an expression and we need to evaluate it. We need to solve it, right? So don't let these fancy words that they try to put in here to trick you. Don't let words like expression trick you. That's what this is, right? It's kind of telling you that. So just don't be fooled by those challenging vocabulary words, okay? So we did one of these the other day. This is order of operations. We need to make sure that when we're doing these operations that we are doing them in the correct order. So the order of operations, we've learned this little way of remembering it. PEMDAS. Okay, the P are parentheses. That's what we're going to do first. The reason is because, this is a rule that we have come to, or not me, but a long time ago, whoever made these rules for math decided that we were going to do the parentheses first because it's going to have a big impact on the rest of the problem. So we do what's inside of the parentheses because that's going to have the greatest impact on the outside outcome or the final answer of the problem. So the first thing we're going to do are these parentheses. Then next, the next biggest outcome that's going to happen when we do it are the exponents. Okay, so we do this in these order because from P all the way down to S, this is kind of the order of the biggest impact it's going to have on the answer to the problem. So we start with the biggest impact and we move towards addition and subtraction, which are going to have a smaller impact than multiplication and division, then exponents and parentheses. Okay, so that's why we start with the P. So we do parentheses first, then exponents, then multiplication and division. These ones go together. So whichever one comes first, moving left to right, just like the direction we read, left to right, you're going to do those before you do addition and subtraction. And same thing. Those kind of go as a pair. So if subtraction comes before addition, when we go from left to right, you're going to do subtraction first. So these two kind of go together. Same thing with multiplication and division. Since they are opposites, they don't have any more effect on the final answer than the other one does, right? So multiplication and division have the same effect on what the final answer is going to be. So we can do those, either one, whichever one comes first. But these parentheses and these exponents need to go first because if you look at this, these parentheses are pretty complicated, but then you get to this exponent. This is going to have a big change in what the answer to this problem is. So we need to do those first before we get to the multiplication and division. All right. So enough talking. First we're doing is P, parentheses. So we have 2 sets of them. If you were to have an exponent in the parentheses, you would have to do it because you want to do everything inside the parentheses first. Okay. So I'm going to rewrite this whole problem over here. 3 times 4 in parentheses, plus 10 to the second power, that's an exponent, minus 9 times 8 plus 2 in parentheses. So just check carefully. 3 times 4 plus 10 to the second power minus 9 times 8 plus 2. And the first thing we're doing here are the parentheses. So we can do 3 times 4 is 12. And we can do 9 times 8 is 72. Plus 2 is 74. So far we've just gotten rid of the parentheses and the parentheses. The rest of the problem we're just going to rewrite. Plus 10 to the second power minus the 74. So all we did so far were the parentheses. Now we have 12 plus 10 to the second power minus 74. So we're not going to do this addition yet. We need to do the exponents first. So 10 to the second power is not 10 times 2. It's not 20. A power means that you're multiplying it by itself that number of times. So you're doing 10 times itself twice. So this is really 10 times 10. So 10 to the second power is 10 times 10, which is 100. Okay, so if you got confused there, I understand. I know that one kid who sent in their work early put 20 there, and that's where that person went wrong. So we have 12. I'm just going to rewrite the rest of it. 12 plus 100 minus 74. So we have 12 plus 100 minus 74. Now we have an addition and subtraction. We're just going to work from left to right. 12 plus 100 is 112 minus 74. And 112 minus 74, let's do that over here. 112 minus 74. If you have two ones, you can't take 4 ones away from it. Can't do 2 minus 4, so we're going to borrow. We're going to take 1 from the tens place, and we're going to trade it for 10 ones, which makes this 12, right? Because this is the tens place is 10 times more than the ones place. So we can take 1 from here and add 10 to here, and then we really didn't change the value of 112. So 12 minus 4 is 8. You can't do 0 minus 7, so you borrow, you add 10 to here, and now 10 minus 7 is 3. So the final answer for this problem is 38. 112 minus 74, the answer to that expression is 38. Okay? Give yourself some snaps if you got that. That was pretty complicated, and we're going to do a couple more that are a little more complicated as we move through. Okay, so now we have number 2. So what's interesting about these where you have like an A, B, and C, it's not telling us to choose A, B, or C. We have to actually solve A, and then solve B, and then solve C. So what's interesting about these ones, you have to be especially careful. Because if you get one of these wrong, you get 0 points for this question number 2. Because you need to show that you really know how to do this. And if you get one of them wrong, then that means you don't really know how to do it. You got a couple of them right, but if you're not perfect, that means you have not mastered this standard. So we give you a few different ones to see, does this kid really know this math, right? And if you don't, then you're going to get one of them wrong. So you got to be really careful, because I see some kids who know how to do this. They go too fast because there's 3 of them and they try to rush through it. Then they get one wrong, and you end up, even if you got 2 of these right, you end up with 0 points for number 2. So you got to really be careful and take your time, especially on these where you have to solve more than one problem. Okay, so I'm setting up number 2 on a blank piece of paper here. It says solve the following inequalities. Again, I put that there to trick you. These are inequalities. Okay. Using the correct symbol, we're going to use less than, greater than, or equal to. We're going to put the symbol in here. So 3/16 is less than, greater than, or equal to 1/4. So we're going to start with that over here. I got 2, I got A, 3/16 or 1/4. Okay, so there's 2 good strategies you could use for this. So 16 and 4, I know that those numbers work together very well because 4 can multiply to get to 16. So we can leave this one as 16 and we can turn this one into 16ths. So if we did 1/4, we're going to make an equivalent fraction for 16th. So we're going to multiply. To get to 16, we had to do 4 times 4. So since we multiplied the denominator times 4, we're going to have to multiply the numerator times the same number, times 4. That way, I've been saying this a lot, we really multiplied that fraction times 4/4. And 4/4 equals 1. And when you multiply a number times 1, it doesn't change that number. It stays the same. So we're not really changing 1/4. We're just making it into a fraction that's equivalent to it. So 4 times 4 was 16, and 1 times 4 is 4/16. So now you can see what's greater, 3/16 or 4/16. If you had 3 out of 16 total pieces in the whole, or if you had 4 out of 16 total pieces in the whole, 4 of those same size pieces is more. So 3/16 is less than 4/16 because 16ths and 16ths means they're the same size. You have 3 pieces or you have 4 pieces of the same size, 4 of them is going to be more. Okay? Another way you could have done this is made the numerators the same. If you changed 1/4, if you turn this, let me just do it here real quick. If you made that into 3, so times what equals 3, we're going to make it so that the numerators are both 3. So we're going to change this one so that the numerator's 3. We had to do 1 times 3 to get to 3. So we're going to do 4 times 3. That way we really did 1/4 times 1 whole. 3/3 is 1 whole. So 1 times 3 got us to 3. That way we both have the same numerators. And then 4 times 3 is 12. So if you look at it this way, this is making common numerators. We have 3 16th size pieces, or we have 3 12th size pieces. And the bigger the denominator, the smaller the pieces, because it's the same size whole cut into 16 pieces they're going to be smaller than if you only cut it into 12 pieces. So we have 3 bigger pieces, 3 smaller pieces. We know that the 3 bigger pieces, again, are greater. So 3/16 is still less than 1/4. Okay, so 3/16 is less than 1/4. I took some time to give you 2 strategies there, so we'll try to go through the rest of these a little bit quicker. Okay, get yourself set up for B. You guys are doing a great job. Give yourself some snaps. You should be proud of yourself if you got that one right. If not, try to think about what strategy you used and where you went wrong. Okay, so now B. 4 times 1/10 plus 7 times 1,000th, or 0.42. So I'm going to rewrite it over here. 4 times 1/10 plus 7 times 1/1000th, or 0.42, or 42 hundredths. So we're trying to figure out, make sure you got the right ones here. 4 times 1/10, good. 7 times 1,000th, good. Because if you wrote that as 100 by accident, you'll get this problem wrong. So 4 times 1/10 is a 4 in the tenths place. They are 4 tenths. The tenths place is right after the decimal point. Plus 7 thousandths would be a 7 in the thousandths place. The next digit is a hundredths place. So we don't have any hundredths. 7 goes in the thousandths place. The tenths place, the hundredths place, and after that is the thousandths place. So check yours now, because if you put 0.47, then your answer is going to be incorrect. It's 4 in the tenths place and then 7 in the thousandths place, not in the hundredths place. So there's no hundredths. And then over here is that less than, greater than, or equal to 0.42. So here we go. There are 4 tenths in both of those numbers. Now we look at the hundredths. There are 0 hundredths and there are 2 hundredths. So 2 hundredths is more than 0 hundredths. So 0.407 is less than 0.42. Or 4 times 1/10 plus 7 times 1,000th is less than 42 hundredths. So the answer to this one is less than. And most likely the mistake you made is you put that in the wrong place. That's the thousandths place, so it needs to go 3 places after the decimal point. The tenths, the hundredths, it has to be in the thousandths place. All right, and then you just compare. Tenths are the same. You go to the hundredths, and there's 0 hundredths here. There's 2 hundredths there. You could have put them both to the thousandths, and you would read that as 407 thousandths or 420 thousandths. 420 is more than 407, and they go to the same place value, so we know that that one's bigger. Okay? And part C, give yourself some snaps. You guys are doing a good job. I'm making these tricky for you. Okay, so now this one, we have 3 1/4. Is that less than, greater than, or equal to? Let's see, we have 5 2/8 minus 1 3/4. So 3 1/4, or 5 2/8 minus 1 3/4. Just double checking that I have the correct numbers here, and I do. So this one already has a mixed number, 3 1/4. Now we need to solve this to figure out what that is as a mixed number. Okay, so let me get some new paper. Give myself plenty of space. We have 5 2/8, and we are subtracting 1 3/4. So I like to line them up vertically. That way we have some space over here to make equivalent fractions. So we're going to make the smaller one bigger, because you can turn 4 into 8. So we got to find out how many eighths that is, because we can't subtract eighths minus fourths. They have to be the same denominator, and these are not yet. So 8 times 2 got us to, 4 times 2 got us to 8. So we're going to multiply the numerator times the same number times 2. Again, that way we are really multiplying it just by 1. 2 halves, 2 over 2 is the same thing as 1. So we're just making equivalent fraction. 4 times 2 is 8, so 3 times 2 is 6/8. So 3/4 and 6/8 are equivalent. Now we can subtract, because we have eighths and we have eighths. But this is where it gets tricky. You have 2/8 minus 6/8. If I only had 2/8 of something, I can't take 6/8 away. So you can't do the subtraction. So we're going to borrow. We'll borrow 1 from the whole number, take 1 away from there, make it 4, and we're going to add 1 to the fraction. And we can do that by seeing the denominator is 8, so we're going to add 1, which is 8/8. So now we have 2/8 plus 8/8. The fractional part is 10/8. So be careful that you don't forget to add it to the 2/8. Some kids just put 8/8 and then they subtract and they get it wrong. So you got to be careful that we had 2/8 and now we're adding 1 more because we subtracted 1 from the whole number. We're adding 1 more, so altogether you have 10/8. So now we have 10/8 minus 6/8 is 4/8. Right, the denominators stay the same, and you just do 10 minus 6 is 4. And then 4 minus 1 wholes is 3 wholes. So we have 3 and 4/8. And in simplest form, we can divide these both by 4. We'll divide by 4/4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So the answer to that, when we did the subtraction, 5 and 2/8 minus 1 and 3/4 was 3.5. So let's go back to this page. We have 3 and 1/4 or 3 and 1/2. 3 wholes and 3 wholes. Now we look at the fraction. 1/4 or 1/2. We have the same numerator. So we don't need to go changing these denominators. We have the same numerator. So it's 1 piece that are fourths or 1 piece that are halves. The bigger the denominator, the smaller the pieces. So 1 out of 4 pieces are smaller than 1 out of 2 bigger pieces. Okay, so again, it is less than. 3 and 1/4 is less than 5 and 2/8 minus 1 and 3/4. And that was pretty tricky because you had to be able to do the subtraction. So if you got that, give yourself some snaps. Great work. Okay, last problem. Here we go. It is multiplication. We haven't done this since we were back in school. So 372 times 24. Give yourself plenty of space. Nice and neat. 372 times 24. Make sure you have the right numbers. Last problem. We're almost done, guys. Good job hanging in there. Okay, so what we're doing here is we're multiplying 372 times 4. So we can ignore the 20 first. We're going to do 372 times 4. Then we're going to add that to 372 times 20. Because that 2 in the tens place isn't just 2, it's 20. So we're going to have 2 separate partial products here, which I'll show you in a second. And we're going to add those together because we had to really do 2 multiplication problems here. 372 times 4 and then 372 times 20. Okay, so we'll start with right here. I always start in the bottom right-hand corner. That's where you start with the multiplication algorithm. Then you go up to the ones place first. Ones to the ones. So 4 times 2 would be 8 ones. Then we go to the tens place. 4 times 7 tens, that's really 70, right? But in our heads, we're doing 4 times 7 is 28, which is really 280, right? Because it's 70 times 4 is 280. So we can put the 80 here, and we can carry the 200 over to the hundreds place, right? But what we're really doing is 28. We put the 8 in the 20, but since that's really 70, you have to have this 8 being in the tens place. And that 200 needs to go over to the 200s place. Or to the hundreds place, sorry. Then we do 4 times 300 is 12. So 4 times 3 is 12, plus the 2 more hundreds that we carried makes 1400s, right? Because these 200s from 280 got carried over to here. So we need to add them at the end. 4 times 3 is 12, plus 2 is 14. But again, this is 300. So 4 times 300 is 1200 or 1200. Plus 2 more hundred is 1400. So you see how we end up with this answer of 1488. That's our first partial product. We already added the 2, so I'm going to cross it off so I don't accidentally use it again. Now we've done 372 times 4, so we're actually going to be done with the 4. We already used it. So here's the tricky part. I learned as a kid you just have to put a 0 here and I put a smiley face to remind myself that there's no math that involved that. Like I didn't multiply anything here to get to 0, but you have to hold the ones place. And watch why. Because this, like I said earlier, we're looking at it as a 2, but it's really a 2 in the tens place. That's 24. So this is 20. So we're doing 20 times 2, and 20 times 2 is 40. If we didn't put this 0 here, we would do 20 times 2, and we'd put a 4 there being 4 ones. And that's not accurate. 20 times 2 is 40. So we have to put this 0 to hold the ones place, because now we're in the tens place doing 220 really times 2, which gets us to 40. So if you don't put this 0 here with the smiley face in the ones place when you go to your second partial product, then you will be in the wrong place value for the whole problem, and your answer will be wrong. Okay? 20 times 2 is 40, so we got to have that 0 there. Now we do 2 times 7, which is really 20 times 70, but 2 times 7 is 14. We're writing the 4 here, and we're carrying the 100 over to here. Okay? So 20 times 40 is 1,400, so you had to put the 4 in the hundreds place, and we're going to carry over to here. Then we do 2 times 3 is 6, plus 1 is 7. So that's 20 times 300. So that's 20 times 300 is 6,000, right? Plus the one more thousand makes 7,000. And you'll see how that works out with the place value. Okay, so it seems simple. We're just multiplying these numbers, but you do have to understand the place value behind it, or you're going to make little mistakes with that. So watch that video again if you were a little confused about this second partial product. Okay, but this is 20 times 2, so it has to come out to 40. But we just do 2 times 2 is 4. We just had to put the 0 there to hold that place. And then everything else lands in the right place value. Now we just add these partial products up. We did 372 times 4, which got us to 1,488. Then we did 372 times 20, which got us to 7,440. Now we add them. 8 plus 0. 8 plus 4 is 12. Carry the 1. 4 plus 4 is 8. Plus 1 is 9. And then 1 plus 7 is 8,000. So the answer is 8,928. 8,928. Give yourself some snaps if you got that. Those were the answers for today. Okay. Let's see. Here's tomorrow's problems. Is this for the all? No, that's for the All-Star. Tomorrow's problems I will give you later. You can check in your assignments for tomorrow's problems and work on them at that point. All right, guys. Have a great day. We'll see you guys. We got one more day till vacation. Enjoy, and that's it. See ya.